Okay, hello everybody, what's going on? This is Muhammad. Welcome to another video. In this video, I'm going to show you how to solve for this Olympiad problem. So given two real numbers, x and y, where x is greater than 1 and y is greater than 1, we need to prove that x divided by the square root of y minus 1 plus y divided by the square root of x minus 1 is greater than or equal 4. So if you're interested, pause this video, give this problem a try, and then keep watching this video for a solution. Okay, so now to prove this inequality, let's start by writing the word proof here. Okay, so the proof of this, okay, we're gonna do the following. We're gonna let x equals, we're gonna define two new variables, which is u and v. Okay, so we're gonna let u equals the square root of x minus 1. Okay, and we're gonna let v equals the square root of y minus 1. Okay, and since x is greater than 1 and y is greater than 1, that makes u and v two positive real numbers. Okay, so since x is greater than 1 and y is greater than 1, that makes u and v greater than or equal to 0. Okay, and then let's square, okay, both sides of the above two equations. So that means u squared, okay, becomes equals to x minus 1. And from that, we can get an expression for x, which becomes u squared plus 1. And we're going to do the same thing for the second equation. Okay, so v squared is equal to y minus 1, and from that we can get an expression for y, which is equal to v squared plus 1. Okay, now we're gonna go back to the original inequality that we need to prove, and we're gonna rewrite it in terms of u and v, the two variables, okay, that we have introduced here. Okay, so x, we're gonna replace x by x is gonna be replaced by u squared plus 1 here. Okay, so u squared plus 1, and the square root of y minus 1 is going to be replaced by, is going to be replaced here by v. Okay, so divided by v, and the second term, okay, which is y, okay, y becomes v squared plus 1. Okay, so v squared plus 1 divided by the square root of x minus 1, which is nothing but the square root of x minus 1, which is basically u. Okay, so this becomes u, and we need to prove that this is greater than or equal to 4. Okay, so now looking at the, we're going to look at the left-hand side here. We're going to look at the numerators here. So we're going to start with the numerators, and we're going to apply the arithmetic mean, geometric mean inequality. Okay, so applying the arithmetic mean, geometric mean inequality. Okay, so that gives us what exactly? Now we're going to start with the numerator. Okay, u squared plus 1. That is, if we divide this by 2, okay, then this should be greater than or equal the square root of u squared multiplied by 1, which is nothing but u, since u is a positive quantity. Okay, let me just replace this by a straight line here. Okay, and we're going to do the same thing for the second numerator, which is v squared plus 1 divided by 2, is going to give us what exactly? Is going to be greater than or equal the square root of v squared multiplied by 1, which is nothing but v. And then we're going to multiply both sides, okay, by 2, both inequalities by 2. So now u squared plus 1 is greater than twice u, and v squared plus 1 is greater than twice v. Okay, and then we're gonna divide both equations. The first equation, the first inequality on the left by v, and the second by u. Okay, so u squared plus 1 divided by v is going to be greater than or equal twice u divided by v, And the second equation, v squared plus 1, we're going to divide that by u, okay? And this is going to be greater than twice v divided by u. And the reason, okay, why we divided by v and u is to get an expression analogous, okay, to the original or equivalent to the expression that we need to prove here, okay? So now, if you guys pay attention, okay, this term here is the same as this term here, and the term here is the same as the term here, okay? So now we need to add up these two terms, okay? So adding the two inequalities would give us the following, okay? So summing would give us what exactly? That u squared plus 1 divided by v plus v squared plus 1 divided by u would be greater than or equal twice, and then we can take 2 as a common factor, u divided by v plus v divided by u. And then we're going to apply again the arithmetic mean and geometric mean inequality for this particular side here. So this is going to be greater than or equal twice multiplied by 2 again, okay? Because, and this is going to be the square root of the multiplication of u divided by v multiplied by v divided by u, which is nothing but 1. So that makes this greater than or equal to 4, and that proves our inequality. And that's it. That's the final answer. If you like this video, don't forget to hit like and post any comment to this video and share it with your friends. If this is your first time here and you want to know more about brain teasers, riddles, logic puzzles, viral math problems, and all types of mathematics related problems, then start now by subscribing to the channel and clicking the bell so you don't miss anything in the future. Thank you for watching and see you in another video.